Hello, algebra students. This lesson is going to be on domain and range. This is part 2, so if you did not see part 1 of this lesson, you should start with that and then come back to this video. And this is our final lesson in our unit on functions. So that means after we finish up this lesson, we'll have our last benchmark of this unit. On the screen is a warm-up. This question comes from part 1 of domain and range. Pause the video now and try to answer this question because it'll be a good reminder to help get you ready for part 2 of this lesson. All right, hopefully you paused the video and you tried this problem. The question is asking us for domain and range. I do think I've said it in just about every single lesson here. As you're reading through these stories, a good starting point for every single one of these problems is to identify your input and your output. We are given that key phrase is a function of, and so we know when we see that phrase, what comes before it is always your output, and what comes after that phrase is your input. So that must mean for this situation here, our input is going to be the number of students, and the output is going to be the cost of the field trip. I'm just going to write trip here. So when we go to answer domain and range, knowing the input and the output are going to be really important. The domain is us describing all of the possible inputs, and the range is going to be us describing all of the possible outputs. Here, since number of students is our input, I know for my domain, I want to describe the type of numbers you can have for a number of students. For example, I know I can't have -5 students. I know I can't have 1.2 students. And so my domain here would be all whole numbers. Sometimes we're given like a minimum or a maximum. In this story, we're not. So it seems like all whole numbers are possible. Maybe 0 students end up going, maybe 100 students end up going. It just has to be a whole number. For the range we're describing the output, which is the cost of the trip. And here, thinking about our range, this information here about it being $30 per student is going to be really important. For example, if it's $30 per student, there's no way for it to cost $31 because it's $30 for each student. Therefore, our range is going to be going up by 30. Like $30 would be possible, $60 is possible, $90 is possible. And so we've learned to describe that as multiples of 30. Again, we've seen with range sometimes there's a minimum or a maximum, but here, since there is no minimum or maximum for the number of students, means there's no minimum or maximum for the cost of the trip. We'll just say multiples of 30. This is where we had left off in part 1, was given a situation like a story like this, can we identify domain and range? In part 2, our focus is going to be on graphs. So notice that word graph there is bolded. The lesson that you're about to look at is all about analyzing graphs of functions to learn about their domain and range. The first thing I have is just a reminder from part 1, our definitions of domain and range. We use these on the warm-up. Domain of a function is going to be the set of all of the possible input values. Here, the word input is really important. And then range, the range of a function is the set of all the possible output values. And so again, we're going to be identifying domain and range, focusing in on graphs. This lesson is also going to be really great practice for everything we've learned about with graphs of functions. We're going to be combining a lot of different skills from this unit. For the first part of this lesson, our main focus is going to be the situation about a swing. We've got a child gets on a swing in a playground, swings for 30 seconds, and then gets off the swing. Here are descriptions of 3 functions and the situations and the 3 graphs representing them. The first thing we're going to do in a moment is we are going to match these 3 functions with the 3 graphs that could represent them. After we've done that matching, I'm going to have you do some labeling on the graph. Before we look at these 3 descriptions, just some vocabulary I want to make sure you're aware of. Swing seat, when we're talking about the seat of the swing, we're talking about this part right here, the part that a child would be sitting on. One of the descriptions is also going to mention the top beam of a swing. My picture here is a little cut off, but when you think of a swing, the swing chains that girl is holding are attached to a metal thing like that. And so this part right here is what they're calling the top beam. Understanding those are going to be important for us understanding these descriptions. And so the three descriptions we are looking at and the three graphs are right here. We have function h, function d, and function s. As I mentioned earlier, the first thing we're going to do is read through these three descriptions and match them up with the three graphs below. I'm going to have you go ahead, pause the video, and try this. This is review from previous lessons we've done on graphing, and so hopefully you're able to match these up okay. Come back to the video when you have an answer. Before we go over how you should have matched these up, I just want to take a moment to look at these three graphs and make some observations. Looking at this first graph, we've got this graph we've never seen before, right? It's kind of got like these stair steps to them where it stays at the same number here and then jumps up to the next number and then jumps up to the next number. We've also got these different looking points here. And if you remember back to inequalities, it's similar to that idea where this empty circle here, that open circle, means there's not a point there. There's a point though at this colored in circle, this closed circle. And so we've got a point here, points here, points here, points here, all the way up until here, where this is where that point is. Looking at the next graph, we see this horizontal line here, which we've talked a lot about with the word constant, right? Whatever this y-axis is, I don't know because it's not labeled yet, but whatever it is remaining constant the whole time. It's not increasing, it's not decreasing. And then with our final graph, you want to talk about increasing and decreasing. This is something where whatever we're looking at is going up, then down, then up, then down, then up, and down. It's increasing, then decreasing. It's getting bigger, then smaller, until about like the middle, and then it starts to, whatever that maximum is it's getting to, starts to decrease again. Usually when I do this in person with students, this middle graph here is the easiest one to place because it's what we're most familiar with, right? It's that constant. And so thinking about the three things we are looking at, the height of the swing, the distance from the swing seat to the top beam, and the total number of times an adult's pushing the swing, only one of those things is constant, and that is going to be our function D here. I'm going to go ahead and label this as function D. When you think about the distance from the swing seat to the top beam, that is the same distance no matter where that swing is. If your swing is just hanging here, that distance from the top to the seat, from the beam to the seat, that distance is the same when it's just hanging or when, draw another picture, or when it's out here, right? It's just going to be the distance of those chains. And so that distance is never changing, even when the swing is moving. I'm going to erase my pictures to make room for the next one. So then we're left with this thing that's going up and down, up and down, up and down. And then this other one where we're kind of skipping over some numbers as it goes up and getting those stair steps. I'm going to go over to this next one, the one that's going up and down and up and down and up and down. That is going to be our function h here. Function h. I know it is function h because that's talking about the actual height of the swing. And so when you think about a swing and it's moving up and down, that's where we're getting this line here. At the beginning, it was maybe at the lowest point, but then as the kid starts to swing, the height goes up, and then when you swing back, it goes down again. You swing up, and the height increases, and then as you swing back down, the height decreases again. And so function h is going to be our height of the swing. Oh, sorry, and goes with this last graph. And then finally, this one right here goes with function S. And to help explain why this is function S, I want to go and do the second part of this, which is labeling your X and your Y axis. Remember, your x-axis, this horizontal one, is always going to be the input, and then your y-axis is going to be your output, or that vertical axis is your output. And so let's go ahead and I'll do D as an example and then have you pause and try the other two. For example, D, I can tell reading through this, and since it uses that phrase as a function of, that time is my input. So that means down here is time. Specifically time since the child gets on the swing. And then my output, which is going to go on my y-axis, is the distance from the swing seat to the top beam. So, oh goodness, can I write sideways? It is our distance from a seat to the top beam. I tried to do that as best as I could. And so our graph is showing that distance from the seat to the beam, that distance is never changing. It's never increasing or decreasing. The same thing I did here for function D. Go ahead, pause the video and see if you can do for function H and function S. All right, I went ahead and put those labels up there. For function H, the same way I figured out function D, I know my x-axis is time again. Notice it was time for all three of these. And then my y-axis or my vertical axis is going to be the height of swing. So again, this is function H because we see as you're swinging, the height's going to go up and down and up and down and up and down. For function S, using that same reasoning, I know my horizontal axis, my x-axis is time, and my y-axis is the number of pushes. I think this graph makes a lot more sense when you put those labels there, because as I'm looking at it, when the child first gets on the swing, we're at 0 pushes because they're not moving yet. But after a little bit of time has passed, it's going to jump from 0 push up to 1 push. And so our line is jumping like that with those stair steps because I'm never going to have a point right here at half a push, right? It's either the kid has gotten 0 pushes or 1 push. And so you can actually see how many pushes that kid got while they were on the swing. We get these longer stretches here because maybe at this time they had 1, 2, 3, 4, 5 pushes. And at this point in time, they still had 5 pushes, just meaning from here to here, they hadn't gotten another push. So our graph is showing at a specific time how many total pushes that child had gotten on the swing. I went ahead and I copied our labels down here to get to the next part. So now that we've got the graphs matched with the stories and we've got our X and Y axis labeled, the next thing we're going to do is use this new information on the screen to go ahead and actually put some numbers on our X and Y axis. And so here there are 5 bullet points. I'm going to ask you to pause the video again. Make sure you're doing that because it's good practice. That's the best way to learn this. But pause the video and use these 5 bullet points here to add some numbers to the graph. For example, the first one tells me the child is given 30 seconds on the swing. That tells me when I go and look at my x-axis on all 3 of these graphs, since all 3 of them are talking about time, that the graph ends at 30 seconds. So that means these final points for each of these are at the number 30. Whoops, not there. Right here. Our x-axis is taken care of now, but our y-axis, those need some numbers. And so you're going to use these remaining bullet points here to go ahead and label these 3 graphs. Pause the video and try that now. For this next bullet point here, we've got when the child is on the swing, an adult pushes the swing a total of 5 times. Since we're talking about how many pushes the child's getting on the swing, I know I'm talking about function S, this first graph here. And that 5 times is something we already kind of figured out looking at this. But I know that this top one right here, that's our total, our maximum. And so that is going to be at the number 5. You could have also labeled 1, 2, 3, and 4 if you want. For the next bullet point, we've got the swing is 1.5 feet above ground, or 18 inches. Since that's talking about the swing's height, that helps me know I must be looking at function h. And then if the swing is 1.5 feet above ground, I'm going to draw my sad picture of a swing set again. That's telling me that if I was looking at the ground, this swing, when it's just hanging there, is the 18 inches or 1.5 feet up. And so thinking about the height of the swing, that is this lowest point here. That's going to be that minimum 1.5. Now that's if my height is in feet. If I had it in inches, that would be a different number. The next one, we've got the chains that hold the seat and suspend it from the top beam are 7 feet long. I'm glad my picture's still there because I'm going to use that again. It's talking about the chains that hold the seat. So that's these right here that I'm putting in pink. And those chains are 7 feet long. What does that help me know? Well, we've got function D is talking about the distance from the seat to the top beam. And we had said earlier that's constant because no matter if the swing is hanging down here or up in the air, that distance from the seat to the top beam is always going to be the length of those chains. And now I know those chains are 7 feet. So right there must be the number 7. I'm going to keep doing it in different colors. Oops. And so I used this. And so there's one bullet point left. The highest point that the child swings up to is 4 feet above the ground. So now I know when that swing goes up, the highest that swing is from the ground is 4 feet. Again, that's talking about the height of the swing. I know the highest point, so right here, if I track it over, is the number 4. Notice as we were doing these, again, similar to when we had talked about features of graphs, some of the emphasis here is really on the minimums and maximums, right? If I think about this last graph here, we were really focused on the lowest the swing ever is from the ground and then the highest the swing is from the ground. Here with the number of pushes, I can tell it's at 0. So I know the lowest amount of pushes, and then we're focused in on the largest amount. The maximum total pushes that child gets is 5. And then similar with the time too. This is what we need for the final part, which is connecting it all together and connecting it to domain and range. So I've copied our graphs down, and the final part to this is identifying the domain and range from each of these graphs. When we think back to part 1 of this lesson and some of the problems we did yesterday, the idea for domain and range is still the same. We're trying to describe all the possible inputs and all the possible outputs. And while we're doing that, we said yesterday it's important to remember the types of numbers that are okay. For example, can you have negative numbers, positive numbers? Do they have to be whole numbers, or are fractions and decimals also okay? All of those are going to be important for this part here. I'm going to start with the domain of this first graph. And with the domain, it means I'm considering the input, which here is time, the time the child is on the swing. Thinking of time can be any type of number, right? It can be a fraction, a decimal, a whole number. So I'm going to start by saying all numbers. It can't just be all numbers though, because it can't be a negative number. So I know the smallest time we're thinking of here is 0. There is also a maximum time here, the 30 seconds. So I'm going to say my domain is all numbers or all values between 0 to 30. When we're considering this child on the swing and how long they've been on the swing, you could have 3 seconds, 10.5 seconds, anything between 0 to 30 seconds. And because all 3 of these functions have time as their input, this domain is going to be true for all three of these. So I'm going to do that to save us some time. The other thing I'm going to do for this first graph is I want to think of the range. Just like yesterday, when we're considering the range, we're trying to describe all of the possible outputs, all of the possible numbers of pushes, and what type of numbers those can be. So just like yesterday, I want to ask myself, does it have to be a whole number, or can it be fractions and decimals? Does it have to be positive, or can it be negative? For the number of pushes here, we had mentioned earlier, the reason this graph looks a little different for us is because we aren't including those fractions and decimal numbers. Our range, I'm going to start by describing it has to be a whole number. We can't have half a push. Can it be any whole number? Well, looking at our graph, I can see there's specific numbers it can be. It's not just any whole number. It's going to be whole numbers between 0 and the maximum we have here is 5. So my range is whole numbers from 0 to 5. Use this first one here as an example and pause the video and try these final two. For our second graph here, our range, this one's a little strange. Our range is just the number 7. If we think about the output here, every single time the output is the number 7. It's not ever a different number. So our range, you can just describe as the number 7. For our final one, our range, we are describing all of the possible numbers for the height of the swing. When you're talking about the height of the swing, you can have fractions or decimals for your height. It could be, 3.5 feet above the ground. So I'm not going to say whole numbers. I'm going to say all numbers. But it just can't be any number, right? Again, I see, looking at our graph, there's a minimum and a maximum. So our range, I'm going to say, is all numbers from 1.5 through 4. Notice that the height of the swing always stays in this area here. There's never a point in time where it's a number not between 1.5 to 4. And so our range is all numbers from 1.5 to 4. This is the goal for today, is looking at these graphs and identifying domain and range. I have 2 extra problems here for us to get some practice. This first graph here, we're looking at the height of an object in time in seconds, and I'm asking you to identify the domain. And then for the second one, it's people in a store. So you're looking at the number of people in the store at a specific time. And for that second graph, I'm asking you to identify the range. Go ahead, pause the video. This will be a great way for you to check in and see how you're doing on this topic. For this first problem, to identify the domain, I'm really focused in on the input, which is always going to be on my x-axis, so the time. The domain, I'm describing all of the possible times based on this graph. Because we're talking about time, it can be any number, right? So I'm going to say all numbers. That includes your whole numbers, your fractions, your decimals. And looking at our graph here, it's all numbers from 0 to 8. Every single time between 0 to 8 seconds has a point on this graph. For the range of the second graph, again, range is all of the possible outputs, so I'm focused here on the number of people. For range, since we're talking about a number of people, we have to have a whole number. I'm going to say whole numbers. But it's not just any whole number. Now, a mistake students make a lot is they look at the y-axis and they say, okay, it's numbered from 0 to 25. So my range is going to be 0 through 25. That is not right because I'm really just focused where that line is. Notice the line, some of those points are labeled. This lowest point right here on the graph is at the number 2. The smallest amount of people in the store based on this graph was 2 people. And it goes from 2 people all the way up to that largest amount, the maximum number of people in the store is right here at 22. So my range at any given time, there must be between 2 to 22 people in the store. So my range is whole numbers from 2 to 22. I have one final question to help us practice this, and it is right here on the screen. It's about a backyard pool. There are 2 questions for you to answer one final time. Pause the video and see how you do. For this final question here, the first question is asking, is 250 in the range of function W? If 250 is in the range, that means there's at some point in time a point where the temperature gets to 250, where the output is 250. If I look at this graph, I see the number 250 on my y-axis, but notice there is no point there. Our graph of that line never gets up to 250. So here I'm going to say no, there is no point where the temperature is 250 degrees. Something like that, I think, is a good way to explain how you know. So for the second part then, if we want to describe the range of the function, now I'm describing the range and I want to come up with a description of all of those possible numbers. Because we're talking about temperature, temperature is another thing like height where you can have those decimals or fractions. If you've ever taken your own temperature, 98.6 is a good example of how you can have those decimals. So for my range, I'm going to go ahead and say all values, not whole numbers, all values. And then looking at this graph, I want to get the minimum and the maximum our temperature is in this situation. So notice the smallest or the lowest the temperature ever is right here. That number between 50 and 100 is 75. And then the maximum temperature, it looks like, is this stretch right here. So that's going to be the number between 200 and 225. I think any good guess in like the 210, 215 area would be good. I'm going to put 212. So we've got our range is all values from 75 up until 212 because the temperature always falls in that range there. You did it. You finished your very last lesson for this unit on functions. Thanks so much for watching. I hope you're feeling more confident about domain and range. And yeah, I'll see you in the next one.